All right, welcome back. Yesterday we did linear, so today we're going to do non-linear. So it's going to be non-linear slash non-linear modeling. Let's take a look at some of these questions. So first one here, nice multiple choice. A piece of machinery initially worth 56,000 depreciates at 8% per annum. Which graph best shows the salvage value of this piece of machinery over time? Okay, now if something depreciates at 8% per annum, we don't talk about it often. But this is essentially something that it's never truly going to reach zero. It's going to get smaller and smaller, but because it's depreciating at 8% per annum, what you'll find is just that the value will get smaller and smaller and smaller, but it will never hit zero. Um, so you can see here with some of these questions here, it can't be D because that reaches zero. It can't be C because eventually that reaches zero. So looking at these two here, I can almost tell you that it's just going to be A straight away. And it cannot be B because B kind of hits zero. I know it doesn't look like it does, but yeah, it does not. Now, the easiest way to test this is just to make sure that you are correct. Plug in something like 30. Okay, so if it's 8% per annum, depreciation kind of works as this will be our declining balance method. So it's going to be our salvage value, sorry, is going to be our initial, so 56,000, 1 minus 8%, whoops, 8% to the power of 30. And you're going to tell me what that answer is. Let's go 56,000 times 1 minus 8% to the power of 30. And I don't know why I did that. But here you can see that it is $4,590 and 1 cents. So 11 cents. So you can see here that does make sense because B definitely goes to zero. So long story short, when something depreciates by a percentage, it will never hit zero. Very similar to a reciprocal function, okay, or your hyperbola, it will never truly reach zero. Okay. Now, for this one here is going to take a little bit more effort, I think. It says a movie theater has 200 seats. Each ticket currently costs $8. So let's note that. The theater owners are currently selling all 200 tickets for each session. They decide to increase the price of tickets to see if they can increase the income earned from each movie session. It's assumed that, by the way, $8 for a ticket, man, you are dreaming. It is this was, I don't know when this question was written. It is assumed that for each $1 increase in ticket price, there will be 10 fewer tickets sold. A graph showing the relationship between an increase in ticket price and the income is shown below. Okay, so let's take a look at this question. So here's your nice little graph. And so you can see what it's saying here is that if we increase the ticket price, it's like at some point we'll hit a maximum point. But then afterwards, it's like because we increase it and it becomes too expensive, less and less people will buy it. If I increase the ticket price by $20, no one's going to go to the movies. That's what it's trying to say. Okay, so question one, what ticket price should be charged to maximize the income from a movie session? So you can see the maximum is actually right here. And so if we're talking about what ticket price, you got to be careful. You can see here that it means that I need to increase by $6, but I'm not going to charge a $6 ticket. This is talking about the price increase, okay, between an increase in ticket price. So here it needs to increase by $6, and we know that each ticket currently costs $8. So that means 8 plus 6 will be a total of $14. That's your 1 mark. Okay. That's the ticket price that should be charged. Now, what is the number of tickets sold when the income is maximized? So this is where I have to kind of go back to the question. And you said here, for each $1 increase, there'll be 10 fewer tickets sold. Okay, so that means they're currently selling all 200. And so if it's $6 increase, that means for each dollar increase, we lose 10 people, right? 10 fewer tickets sold. So if it's a $6 increase, 6 times 10, it's 60 less tickets. Tickets. Oh my goodness, tickets. It's going to be 60 less tickets. So we started with 200 and we take away 60. That's going to be 104. Oops, not $140. It'll be 140 tickets. Okay. Now, that's your 2 marks. Now, the third one here, it says the cost to the theater owners of running each session is $500 plus $2 per ticket sold. Calculate the profit earned by the theater owners when the income earned from a session is maximized. Okay, so we know here, and this is a classic HSC question where part one and part two is going to set you off part three. Okay, so let's do this. We have to find profit. Profit is always the income / revenue minus the cost. Okay, so let's talk about the income or revenue. And I'll write it as revenue. So we said that there was 140 tickets selling for $14 each. And so if I calculate that, 140 times 14, that will give me $1,960. That's your revenue. Now your cost, it says here that the cost is $500 plus $2 per ticket sold. And we know that there has been 140 tickets. So we can see that the cost here would be $780. Okay, now how do I calculate the profit? Which is going to be my revenue minus my cost. And that would be $1,180 profit. There you go. Hopefully that makes sense. And good luck. I will hope to catch you in the next one. See you guys later.